in this question here, you're being asked to draw the products of the following acid-base reaction if treated with one equivalent of strong acid like HCl. All right, so it's just saying one HCl is going to react with this species here. All right, so HCl is an acid. All right, so it's going to be a proton donor here. So something in this species here is going to act as a base. And it's anything that has lone pair electrons. So when we look at this, there's a lone pair on this nitrogen, there's 2 lone pairs on this oxygen, and then there's 2 lone pairs on this oxygen. And we want to know if there's one equivalent of this HCl, which one of these atoms is going to pick up that proton? Which one of these atoms is going to get protonated? So there's 3 possibilities here. And I'm going to draw all 3 of them out. I'm going to draw each one picking up a proton. All right. So here we'll say that, this oxygen on the right picks up a proton. And when it does, it ends up with positive charge. And then we're going to say that this oxygen in the middle here picks up the proton. And it's going to end up with positive charge. And then this one here, we're going to say this nitrogen picks up the proton, and it ends up with positive charge. So here's one way we can answer this. We want to figure out which one of these is going to pick up the proton and end up with positive charge. Well, let's just ask ourselves, which one of these is actually handling the positive charge the best? Okay, and that means whichever one's handling it the best, that means that that atom that picked up the proton was the most basic. All right, so in this case, we have positive charge on the oxygen. And in this one, we have positive charge on the oxygen. No resonance in either of those. In this one, we have positive charge on the nitrogen. Well, we have to ask ourselves, which one's handling the positive charge the best? And that comes down to electronegativity. Oxygen is more electronegative than nitrogen. That means oxygen doesn't want positive charge. It's handling positive charge the worst. So that means these are the least stable. So they're the most unlikely to form here. Nitrogen is less electronegative and therefore handles the positive charge better. So it's okay getting the positive charge. It's okay picking up the proton and getting the positive charge. That means nitrogen in this original species is more basic. It's more willing to send its electrons out to pick up that proton because it handles the positive charge the best. Okay. Another way to think about that is, well, what's going on here? We're using some atom to pick up that proton. Well, which one is gonna send its electrons out to pick up a proton? Basically, what I'm saying is, which of these electrons are most available to do that? Well, if oxygen is more electronegative, it's hanging on to these electrons more tightly. If it's hanging on to them more tightly, they're not going to go out and pick up a proton as easily. Nitrogen, being less electronegative, it's not hanging on to those protons as tightly, which means they're more available to pick up a proton, which means they're more basic, which means these are going to react first. So there's 2 ways to look at it. You can look at it as how tightly the electrons are being held, how available are they to act as a base, or you can look at what happens when it's protonated and compare the stability with the positive charge, and it's much more stable on the nitrogen. That lets us know that this is the product that would form here.